Family letter, content overview. Dear family, in lessons 1 through 7 of Unit 7 of Math Expressions, your child will build on previous experience with fractions. Your child will use both physical models and numerical methods to recognize and to find fractions equivalent to a given fraction. Your child will also compare and order fractions and mixed numbers, including those with like and unlike numerators and denominators. By using fraction strips, students determine how to model and compare fractions and to find equivalent fractions. Your child will also learn how to use multiplication and division to find equivalent fractions. Your child will be introduced to the number line model for fractions. Students name fractions corresponding to given lengths on the number line and identify corresponding lengths to given fractions. They also see that there are many equivalent fraction names for any given length. Your child will apply this knowledge of fractions to word problems and in data displays. If you have questions or problems, please contact me. Thank you. Sincerely, your child's teacher. Which is me, of course. But really, I'm just joking around with you. You know I'm not a teacher. I'm a fish. Chaw! Anyways, as usual, like I said, chaw! I'm a fish. My name is Fish. Chaw! And we are going to introduce you to a new concept, equivalent fractions. We will also learn how to compare them with like and unlike numerators and denominators, including mixed number comparisons. So here were the examples of fraction bar modeling that we talked about last time. Fraction comparisons. Last time we met, we saw that 1/2 was longer than that 1/3 block. So we could see that 1/3 is less than 1/2 because it's further away from a third. In case you didn't know that, you're welcome. Chaw! But there is a new concept in 4th grade math called equivalent fractions. Equivalent fractions are fractions with the same value. It's like the same exact thing. Chaw! Okay, so what we see here is 1/2 of this rectangle and 1/4 of this rectangle, but they both match up. 2/8 is equivalent to 1/4. Yes. Oh, I'm too big. There we go. Anyways, equivalent fractions are what we are kind of going to be learning about today. And also, just for a bonus, we are going to introduce you to a fraction bar up to 1/20th. I know, crazy, right? And then we will get moving right along to lessons 8 through 16 of Math Expressions. Okay, let's flip over the pit. Hello, fish. Ah! Sorry. Hey, Crab. Oh, are you okay, Crab? Yeah. All right. Well, hello there, Squid, and hi, Crab. Oh, hi, Fish. Hi, Fish. What are we going to be learning about today? We are going to be learning about equivalent fractions and some other topics related to fractions, but we'll get to those later. Anyways, let's turn the page. Ow! My beak has been scraped up. Oh, hi, Pelican. Oh, hello. Sorry. It's okay. I didn't know. Darn. Chaw! Anyways. Ooh. What is this? What is this? we have got new vocabulary words today. I did never think we would have new vocabulary words, but we did have new vocabulary words. New vocabulary words? New vocabulary what? Oh, new vocabulary words. Why, hello, shrimp. Oh, hi, pelican. Hi, squid. Hi, crab. Hi, fish. Chaw! Common denominator. Common denominator. This says common denominator. That's right, shrimp. Well, what is a common denominator exactly? Well, let's turn over the page. Let's turn the page to find out. A common denominator is a common multiple of two or more denominators. Oh. Darn. What is a denominator? Delete. It is the bottom number in a fraction that shows the total number of equal parts in a whole. Oh yeah, right. Here. An example of a common denominator of 1/2 and 1/3 is 6, because 6 is a multiple of 2 and 3. Yeah, but 1/2 and 1/3 are both less than 2 and 3. How is that possible? Well, look. 2 and 3 are the denominators, so that's why 6 has to be the answer. Oh, I forgot. Okay. And we have another vocabulary word, but we'll get back to that later. Right now, let's just stick to the fraction ones, okay? Equivalent fractions. What are equivalent fractions? Equivalent fractions are two or more fractions that represent the same number. An example would be 2/4 and 4/8, because they both represent 1/2. 2 times 2 is 4, 4 times 2 is 8, and 1 times 2 is 2. Ah, that makes a lot more sense. Oh, you're starting to understand. I'm really happy to hear that. Thank you. Yep, you're welcome. All right, we'll skip that until later. We'll skip that until later, and we'll skip that until later. Simplify a fraction. What does simplifying a fraction mean? That's what we're going to find out. Simplifying a fraction is basically just dividing the numerator and the denominator of a fraction by the same number to make an equivalent fraction made from fewer but larger unit fractions. An example would be 5/10, because 5 is divisible by 5 and 10 is divisible by 5. So can it be simplified? I don't know. Can it? Yes, it can. Because 5 divided by 5 is 1, and 10 divided by 5 is 2. So 5/10 simplifies to 1/2. Plus, 1 times 2 is 2, and 5 times 2 is 10. Ah. Darn. Okay, and we will skip that until later. Okay, all right. Well, it is bonus time, because just like I promised you, just like I seriously promised you, we have found a secret fraction bar page. A secret fraction bar page? Yes, but this one has got a typo. If you wanted to cut it, then you would cut all your work off. Here you are. What? Ow. Oh yeah, the page scraped my beak. Well, then maybe you should move a bit further away, because I'll be turning pages. All right, I'm ready to learn now. Are you sure the pages are gonna stomp on your beak? I'm sure. Okay. Anyway, like we promised, we found a secret fraction bar page that has a typo, I understand. That lists fraction bars from one whole bar all the way to 1/20th. And then all the 20/20ths. 20/20ths equals one whole. 19/19ths equals one whole. 18/18ths equals one whole. 17/17ths equals one whole. 16/16. Oh, all right, let's keep going. Whoa, I could see the whole fraction system in here. Yes, the fraction system of fraction bars really helps students understand the difference between 1/2 and 2/1. For example, some fourth graders get confused with this fraction over here, 1/2, and they accidentally sometimes do 2/1. That's not right. We cannot swap the denominator as the numerator and the numerator as the denominator. It's a half, not a whole, because if 1 was a denominator, that would stand for a whole. 2 divided by 1 is 2, so 2/1 means 2 wholes, so we can't change that. But we could change this. You wanna know why? Do-de-do. You don't know why. No worries. I'll explain why we could change it. Look, 1 equals 1. They're both literally the same number. So, if 1 as the denominator is switched to 1 as the numerator, then 1 as the numerator will get switched to 1 as the denominator. It would still be 1/1. So we could change that, but not these. Not these. Besides one whole. 1, 1. 1, 1. Same thing. Except we can't switch these. I think I'm getting the hang of this now. Yeah. Oh, yeah, I'm dancing. Oh, hi, lizard. I don't know how you got here. Oh, hello. You see, I found this secret fraction bar page that allows me to dance and run throughout this whole page. It's awesome. Can't you believe it? I know. Like, literally, if we want to cut all these fraction bars off, you would be cutting this hard work off. Here you are. Oh, that's so sad to hear. Well, gotta scamper away. Bye. Yeah. Bye, lizard. Okay. Let's solve these problems. Bao listed the birds that visited his bird feeder on Friday. He said that 2/5 were finches and 2/6 were wrens. Did more finches or more wrens visit the bird feeder? Explain. But 2 is the numerator for 2/5, and 2 is the numerator for 2/6. How will we know which one is greater? Well, there is a way that we just saw in front of our eyes. This one. So, if we look only at the 5ths and the 6ths bar, 1 2/5, 1 2/6. Notice a difference? 2/5 has a longer block distance than 2/6. So 2/5 is greater than 2/6. So, what did we say that 2/5 of the birds were? Well, they were finches. And what did we say 2/6 of the birds were? Wrens. So, did more finches or more wrens visit the bird feeder? More finches, because 2/5 is greater than 2/6. Wait, but it has a smaller denominator. 6 is greater than 5. No. Don't even go down that path. It represents the total number of parts in the whole, not a whole number. So, in this case, 1/5 is not less than 1/6, because even though 5 is less than 6, that only shows the total number of equal parts in the whole, not a whole number like 5 or 6. That makes a lot more sense, because 5 and 6 is totally greater than 2/5 and 2/6. Exactly. So the answer should be that more finches visited the bird feeder. And then you had to explain or draw a model or something else that showed that 2/5 was greater than 2/6. So, on your workbook on this page, you should write finches. If you got wrens, then you must have done something wrong, or maybe you just misunderstood the concept. Take a minute to write all of this down. Okay, as usual, I need 2 fins to write. So I will put the camera to the side, and Pelican will entertain you while I write, okay? Oh, yeah. Hi, guys. For a second thought, I didn't even know about fractions that much. But then, once I understood fractions, I was like, oh, wow. Hey! Why did the camera go down? Why do cameras always have to fall down? Anyways, I was talking like, oh, Pelican, you were so smart. You didn't even know it without the fish's help. Hey, I helped you. Okay, maybe a little bit of fish's help. What? A lot of fish's help. Oh, thank goodness. I helped you a lot. And you too. Okay, you can keep talking to Pelican. I'm leaving. And I'm coming back. So anyway, I was like, wow, fish, you did a great job explaining it to me. I just love to entertain you every single day. Yeah, it's all about the little things in life, as they say. But I'm not little. How does that even change anything? Maybe, well, the world is bigger than me, so maybe I am small. But fish is smaller than me. So, like, yeah. So, yeah, it's all about the little things in life. And I still don't know it. And it was always done. Woo, fish. You don't have to yell like that. Oops. Sorry. Okay, I'm back. And I have finished writing. More finches visited because 2/5 is greater than 2/6. Excuse me. What's that little alligator symbol? Oh, that's just showing that the alligator is eating the greater number. Like 2/5. Because 2/5 is greater than 2/6, the alligator is going to eat 2/5. That makes a lot more sense. All right. Mariel had a box of baseball cards. She kept 3/8 of the cards and gave 5/8 of the cards to Javier, who had more of the cards. Explain. Okay, I think this should be pretty self-explanatory. What do you mean? Well, the denominators are the same. And the numerators, they represent the number in a unit fraction of a fraction. So you could actually really think about it like Squid said. Like 8 is equal to 8. Or 5 is less than 6. Not for the denominators, only for the numerators. 5 is greater than 3, so 5/8 is greater than 3/8. Like, think of a pie. If you have 3/8 of it, and you add 2 more eighths, that will get you a bigger piece of 5/8. So 5/8 is greater than 3/8. So Mariel gave the cards, Mariel gave 5/8 of the cards to Javier. So who had more of the cards? Javier, of course. Well, Javier, that really, really cool Javier of his. Oh my goodness, really? Ah! Sorry. Anyways, like, I did not even understand fractions when I was in middle school at first. But now that Fish taught me, I was like, oh, thank you, Fa! Not thank you, Fa. I was like, thank you, Fish. You brightened up my day, and you taught me something new. Yeah, pretty much every day you learn something new, because every school day, Monday through Friday, you go to school, and you learn something new in school. So, take that. That's it. Pelican, what are you doing? I'm facing the camera this way so that the camera does not disturb my beak all the time. Hey, Pelican, why are you always yelling at me? I don't know, Fish. You're still writing the answer. I know. Just be patient. Then I will face it this way, so that at least the 4th graders will have some entertaining while I'm writing the answer. I'm a giant squid. I could live for 5 years, and I squirt ink. Yeah, I mean, giant squids are really a huge deal to many fishes. Because when fish try to battle me, I'll just squirt ink at them and laugh at them. Yeah, all those really good times. Yeah, really. Done! Ow! Sorry. All right. Javier had more cards. Javier has 5/8 of the cards. 5/8 is greater than 3/8, because 5 is greater than 3, you know. And then number 20, write the fractions 10/12, 5/12, and 7/12 in order from least to greatest. So 5 is the least number in the group. So we'll start with 5/12. Now which number is the least? 10 or 7? 7. You're right. And then 10/12 is the greatest number. Correct. Which rounds up and is closer to 1, which is 12 divided by 12, you know. Good job. Now, we are going to look not only at fraction bars, but also number lines. Every fraction has its fraction count between 0 and 1. Like, 1/2 is exactly between 0 and 1. But 1/4 is half of half, because it's 1/2 of 0 and half. 2/4 is half. 1/4 is half of half. I know. And then 1/8 is half of half of half, because half is half of 1, and then 1/4 is half of half, and then 1/8 is half of 1/4. I know. The fraction pattern keeps going on and on. Forever. You see, they got from whole numbers like 1 to mixed numbers, like these ones, like 1 and 3/4, or 2 and 1/2, etc. So it shows you, like, the 0 ones, it's 0. But anything greater than that will change its value. The greatest fractions will have 5. And then the least fractions, which is 0, will have 0. Obviously. Yeah, obviously. So, not to begin bragging with, but let's turn to the next page. Ow! Age. Ooh. These are so cool. This time there is a number line from 0 all the way to 6. Let's count up the tiny ticks and see how many parts this number line is divided to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's divided into 10 parts. So that means all those 10 parts will make up 1/10. Wait, no. Sorry. 10 tenths. This 1 tick is 1/10. I'm sorry. No, it's fine. All right. Okay. I think we already know about this already. I think we're getting pretty good at fractions. Now, we are going to check out equivalent fractions. You know, fractions that have the same value with the same number. Okay, let's look at this equivalent comparison. We could see that 2/3 is equivalent to 8/12. But how? Well, 2 times 4 is 8, and 3 times 4 is 12. Sure. But there are other ways we could look at it, such as this bar. There are 2/3 of the bar shaded in green, and there are 8/12 of another bar shaded in green. But the lines and the distances match up exactly, which means it's equivalent. But if we just shade 1/3 in green and 4/12 in green, this means that 1/3 is equivalent to 4/12. Because 1 times 4 is 4 and 3 times 4 is 12. Easy peasy lemon squeezy. And then obviously 3/3 will equal 12/12, which equals 1. But besides that, 2 fractions that represent the same part of a whole are equivalent fractions. The fractions 2/3 and 8/12 are equivalent. And like I said before, Maria said you are just fracturing each third into 4/12. You can show what you did using numbers. Here's what Maria wrote. So this is what I said last time. But 2 times 4 is 8, and 3 times 4 is 12. So my method was right. We could get 8/12 just by multiplying 4/4. Wait, no. Just by multiplying 2/3 by 4/4. Like 2 times 4 is 8, 3 times 4 is 12. I'm sorry. No, it's all good. Oh, thank you, Falcon. Anyways. Speaking of that, we are going to learn how to use multiplication and division to find equivalent fractions. Wait, you can use multiplication and division to find equivalent fractions? But how is that even possible? Well, we could see in the multiplication table, 1/2 has 1 as the numerator and 2 as the denominator, right? Yeah. The table on the right shows part of the multiplication table at the left. You can find fractions equivalent to 1/3 by using the products in the rows for the factors 1 and 3, like this. 1, 3, 1, 3. 1 times 6 is 6, 3 times 6 is 18, 6 divided by 6 is 1, and 18 divided by 6 is 3. 6/18 is 1/3. 6/18 and 6/18. Ah! Yes! Yes, yes, yes! So that's how we could use multiplication and division to find equivalent fractions. And also, it's how to simplify a fraction. Well, simplifying is just dividing. But multiplying like this just leaves you with practice to find the equivalent fraction. So yeah, it's really good. Let's look at 8/12. Well, we know it is equivalent to 2/3 because 8 divided by 4 is 4. And 12 divided by 4 is 3. But what about 4/6? Why is 8/12 equivalent to 4/6? Well, 8 divided by 2 is 4, and 12 divided by 2 is 6. Yeah, same thing, just a different fraction, but equivalent to it. Still equivalent. Excuse me. Can you stop doing that? Yeah. Excuse me. That's it. And also, when fractions are improper, that is, the numerator is greater than the denominator, 14 divided by 2 is 7, and 12 divided by 2 is 6, but we are left with a simplified improper fraction. 7 is greater than 6. So it has to simplify down to 1 1/6. That's how mixed numbers are introduced to the simplifying process. So, in all of these group-sized cases, we could see that the numerators go down from 6, 5, 4, 3, 2, and 1. 6, 5, 4, 3, 2, and 1. So we could see that 6, 5, 4, 3, 2, and 1 really play a crucial role in equivalent fractions. And also these matter. Yeah. Yay! Yeah! Oh, that is so cool! Yeah. Did you know that? Let us know by liking and subscribing. Oh, Pelican. To unsimplify a fraction, you multiply. To simplify a fraction, you divide. Yeah. So it is really pretty straightforward here. Yeah. You will eventually get the hang of it. Yeah. And then comparing fractions is kind of like the same thing. The fractions will have a common denominator. You can use different strategies to do this. The ones shown below depend on how the denominators of the two fractions are related. So, they just took 5 times 8, or 40, as the common denominator, and then they multiplied to get 25/40ths. But now they have to do 4 times 8 and 5 times 8 to get 32/40ths. 25/40ths is less than 32/40ths, so 5/8 is less than 4/5. I know, crazy, right? They literally just took the common denominator and unsimplified these fractions by multiplying to compare them. That is so cool. Yeah, I have to agree, Fish. It is really cool. Indeed it is. Adding fractions is the same thing too. look at these. Whoa, tenths and hundredths. Now we are really getting into some good stuff here. 100th plus 100th is 200ths. So it's really, really simple to understand. We're going to skip this data one because it mainly talks about statistics. Yeah. And as I promised, in lessons 8 through 16, we're going to learn decimals. What are decimals? I'll read the family letter. Dear family, in lessons 8 through 16 of Unit 7 of Math Expressions, your child will be introduced to decimal numbers. Students will begin by using what they already know about pennies, dimes, and dollars to see connections between fractions and decimals. Students will explore decimal numbers by using bars divided into tenths and hundredths. They will relate decimals to fractions, which are also used to represent parts of a whole. Students will read, write, and model decimal numbers. They will learn to combine whole numbers with decimals. They will work with numbers such as 9.001, 1.72, and 12.9. Students will compare decimal numbers with other decimal numbers. They will also order decimals from least to greatest or greatest to least. Students will apply their understanding of decimal concepts when they compare and order decimals. Comparing decimals. 6.8 is greater than 3.42 because if we add a 0, 80 is greater than 42. So that's why that adding a 0 makes the numbers easier to compare. Please contact me if you have any questions or comments. Thank you. Sincerely, your child's teacher. Always. Now's the time. Now's the time for what? Time to view the other vocabulary cards. What is a decimal number? Ow. Well, that is what we are going to be learning about. A decimal number is a representation of a number using the numerals 0 to 9, in which each digit has a value 10 times the digit to its right. A dot or decimal point separates the whole number part of the number on the left from the fractional part on the right. Examples of decimal numbers are 1.23 and 0.3. That died. Here's what 100 means. 100 is a unit fraction representing one of 100 parts, written as 0.01 or 100. So, we could see that in this 10 by 10 square grid, that teeny tiny red square that's shaded, that's 100th of the whole entire 10 by 10 square, because 10 by 10 is 100. 10 times 10. 100th equals 1 over 100 equals 0.01. An example of 100th would be this 3, because 7.634. 3, even though it's in the ones place of 63, think about it. 100 has 1, 2 zeros. That's 1, 2 digits to the left of 1. So 6, 3, that's 2 digits to the left of 7. So that's why 3 is the 100th. Oh, so interesting. It is interesting. Now, tenths are the exact same thing, except way more different. 1/10 is a unit fraction representing one of 10 equal parts of a whole, written as 0.1 or 1/10 of this 1 by 10 grid. 3 is a tenth of this number because 10 has 1 0 or 1 digit apart from 1. So 3 is 1 digit away from 12. Then 1,000. A unit fraction representing one of 1,000 equal parts of a whole, written as 0.001 or 1 1,000 or 1/1,000. So let's turn all the way. Too far. I made it too far. Sorry. It's fine. You don't have to say sorry. Draw. So let's look at this money over here. Tenths and hundredths. Pennies and dimes can help you understand tenths and hundredths. Discuss what you see. Okay, guys. So, what do you see? It says 100 pennies equals 10 dimes equals $1. Ooh! I see a thing related to what you said, except they already simplified it. 100 pennies equals $1, and 10 dimes equals $1. Wait, what? A penny is 1/100th of a dollar, and 1 dime is 1/10th of a dollar. Oh yeah, that makes sense, because a penny has 1 cent, and a dime has 10 cents. Oh my goodness. I think I'm getting the hang of this now. Yes, you certainly are, and I'm getting the hang of this too. We all are. Yes. Now, it's 10 of 100 equal parts, but it's 1 of 10 equal parts here from these lines. 0.1 equals 0.10. The 0 does not change its value. And all of the rest of these, look at it. It's just like these fraction bars from 1/whole to 1/20th that we talked about, except they did it differently, only through wholes, tenths, and hundredths. So, that is kind of really nice how they show us these fraction relationships already. And we don't have to write them down. We just have to discuss and have a clear understanding of relating fractions and decimals. Let's turn over to the next page for a second. Do you notice something here? 1 of 2 equal parts. 1/2. That says 5 dimes and 50 pennies. 5/10, 50 hundredths. 50 hundredths. Ooh. 2 of 2 equal parts. 1 of 4 equal parts. This is getting amazing. 4 of 4 equal parts is 1/whole. And 2 of 2 equal parts. Don't forget. So, when it's 1/whole, it's 100 hundredths, or 1 whole dollar bill. 100 pennies, or 10 dimes, equals $1 bill. And fractions greater than 1. 5 of 4 equal parts. Well, that's an improper fraction, so they simplify it to $1 bill and 1/4, because a quarter coin costs 25 cents. Oh, I get it. 4/4 plus 1/4 equals 5/4. 4/4 plus 2/4 equals 6/4, etc. So yeah, it is really nice how they show us these pictures in everyday life. Yeah, it's really, really cool. And really, check understanding. Explain why 0.7 equals 0.70. I think I already said it already, did I? Yeah, I think you did. I think you said it's because it's a 0, and 0 means nothing, so the 0 does not change its value. That is right. Oh my goodness. How did you know that, Pelican? Memory. Here. Ooh. Pelican, come over here. I found something. Huh? What is it? Is it a spider? On my beak? Ah, it's a spider. Get it off. No, it's not a spider. Come over here. Oh, spiders are not green. Secret decimal cards. What are these? Are these secret cards from an ancient pyramid or something? No, of course not. It's in the book. What book? Ah! Oh, that book. 1/10, 100th, 2/10, 200ths, 0.1, 0.01, 0.2, 0.02. This is getting amazing. And then what is 0.00? Oh, that just means 0. And then this is greater than, and this is less than. Oh, like when we are comparing decimal numbers. Exactly, Pelican. So let's turn over. You could see that in the decimal numbers, they represented coins or money behind it, so that you could get another clear understanding of what money, fractions, and decimals should look like. And then for the zeros, of course, they showed nothing, because, 0 means nothing. And then they just show the back of these. It doesn't really matter. It's just the greater than and less than symbol. So yeah, comparing them, adding a 0, makes it easier to compare. But not always. Discuss symmetry around the ones. So here are the hundredths. 100 over 1, 10 over 1, 1 over 1, 1 over 10, 1 over 100. So it's hundredths. You see those red letters, THS? That means that it's divided by 10, or a lesser number. So that's why they had those letters here. And then for the hundreds, tens, and ones, they didn't have those. That's because the number is being multiplied by 10 or greater. It's kind of like symmetry. Think about symmetry. You divide it into 1/2, this whole model. When you fold it, it matches up exactly. That's symmetry. But we'll talk more about symmetry later. If you already did this, well done. But I didn't think you did it. It says use your decimal secret code cards to make numbers on the frame. Yeah. So you could make numbers with your decimal cards to see where place value takes place. Oh, really? Yes. Place value is the aligning of numbers. And then here are the whole numbers I think we should all know. 110, 1, 222, 300, etc. It all looks pretty straightforward. And then at the back, it shows you all the dollar bills you need to understand for each whole number. That's handy. It is really handy. Really, really handy. Let's talk about this for a second. Why does inserting zeros to the right of whole numbers makes the number greater, but inserting zeros on decimal numbers just makes them equal? Well, that's because 30 is greater than 3, but 0.30 is equivalent to 0.3, because that 0 in the hundredths place, well, it doesn't change its value. But it does in whole numbers, because, well, there's no decimal point. 30 has 1 3 and 1 0. So that is why inserting zeros to the left will make a big difference. The whole numbers will be equal, because 3 is still equivalent to 3 with a 0 behind it. But 0 doesn't really matter. You don't even need the 0. And then 6.07. This time, these numbers will get greater. Or lesser. Yeah, I think they'll get lesser. And these will get greater. And these are equal to. What? 0 does not change its value for these and these? Yeah. It does not change its value for these, but it does change its value for these. Can't you believe that? I know, crazy, right? Yeah. All right. So we're just going to skip this because I think we already know that. Extend the place value chart. 1,000 is this. So it would be like 1/10 of a penny. Look how small that little penny is. Whoa. Now I'm seeing kind of double. Yes. And then in case you didn't notice, there are president faces on a $10 bill, a $100 bill, even a $1,000 bill. I haven't noticed until I saw it. 0.2, which is 2/10, equals 0.20, which is 20 hundredths, equals 0.200, which is 200 thousandths. Same thing with 0.9 equals 0.90 equals 0.900. Decimal secret code cards. Well, here they are. Here are the thousands, the whole numbers, and then the thousandths, the decimal numbers. And then here are all these zeros. We don't need those. And it just shows you, like, how many tenths of this penny are in a thousand. Then these nothing for zero. And then for the whole numbers, they show you how many $1,000 bills are there. Yeah. So it really is all pretty much self-explanatory over here. So, yeah, I think once fourth graders get taught this lesson again and again, I think they will understand it pretty well. All right. Unfortunately, that's it for me today. Oh, but don't worry, we will come back another time, won't we? Of course we will, because learning never ends. Bye. We never know where learning will end, but we know where it begins. Math Expressions by HMH, Houghton Mifflin Harcourt. And by Apple Official Channel, of course, with over 3.15 thousand subscribers and counting. From A to Infinity by the National Science Foundation.